Today we are starting Chapter 5, and the first section is Properties and Attributes of Polygons. The definition of a polygon is a shape consisting of straight, non-intersecting line segments. So we did a lot of work with triangles in the last chapter. A triangle is a shape that has straight, non-intersecting line segments. So we've already seen one kind of polygon in Chapter 4. So in example 1, we have 5 figures, and we're asked to determine whether or not the figure is a polygon. So if we use that definition up above, we're looking for a shape that has only straight sides and none of the sides intersect each other. So in the top row, the first one would not be considered a polygon because the corners are rounded. They do not, there's not all straight sides if we have anything rounded. So that one is not a polygon. In the middle, that would be considered a polygon because it's only made up of straight sides. They do not intersect themselves. A circle is a shape we're all familiar with, but it is not considered a polygon because it does not have straight sides. In the bottom row, the first shape would be considered a polygon because, again, it has straight, non-intersecting sides. And the second one would not be considered a polygon because they intersect each other, those sides. Anytime two lines cross over each other, and then you can see, obviously, hopefully, vertical angles in that picture, that would not be considered a polygon. So even though that last figure has straight sides, since they're crossing over each other, not a polygon. We're going to learn 2 more vocabulary words in this next section. The first word we're going to learn is convex. A polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. I'll be a little more specific about what that means in a minute. The next sentence says, a polygon that is not convex is called non-convex or concave. Concave is really the more common vocabulary word we'll see. It's very rare that we would see the word non-convex, although they do mean the same thing. So if we go back up to that first sentence, it says, if no line that contains a side of the polygon contains a point in the interior of the polygon. What that means, if we look down at example 2, is if you extend any side, you would not end up inside the polygon. So this first shape is considered a polygon, but it is considered a concave polygon. And that is because if you took it doesn't have to be any side, but if you could find at least one side that if you extend it, so if I look at this side here and extend it, I end up inside the polygon. And so that's considered concave. Whereas the shape next to it is considered convex because no matter which side I extend, I would never end up inside the polygon. So that's what the definition up above was trying to say. Now, many students can look at these shapes and say they don't really need to extend the lines along the edges because they notice that it kind of goes in on itself. So I look at this first shape and right here or here, any of these 4 places, it actually goes inward. And many students can look at that and say they can tell it's concave just by the look of it. So if you can tell by the way it looks, fine. Otherwise, use the line test where you do that extension on some of the sides and see if you could ever end up inside. So those are your 2 ways, either the line test or just look for a place where the shape goes in on itself. I kind of think of that as like a cave has an entrance. And so where I have those 4 arrows, you can think of that as an entrance into the cave. And so that will help you remember the word concave. All right, so there are 3 vocabulary words on this page that you'll be expected to know. What is a polygon? What does the word convex mean? And what does the word concave mean? All right, on the next page, we're going to ask you to classify polygons by the number of sides they have. And so, like I said at the start of the notes, we've already learned about a 3-sided polygon. That is called a triangle. If we have a 4-sided polygon, it's very common that students will say something like a square or a rectangle. Those are definitely 4-sided polygons, but we want the general term for any shape that has 4 sides. So the correct word there is quadrilateral. So we don't want you to tell me about a specific four-sided shape. If I ask you what a polygon that has four sides is classified as, you should call it a quadrilateral. Now you might want to stop the tape right now and, or the video, I guess it's not a tape, but stop the video now and see which other ones you already know, and then come back and see if you got them right. All right, so if you tried these on your own, I think sometimes you already know many of these, either from maybe a science class or maybe just you know them from some other class. So a five-sided shape is called a pentagon. Hopefully you think about the Pentagon building in Washington, D.C. A six-sided shape is called a hexagon. A seven-sided shape is called a heptagon. An eight-sided shape, most people know that because of the stop sign, that's called an octagon. A lot of people do not know what a nine-sided shape is called. It is called a nonagon. Many people know a 10-sided shape. It's called a decagon. And a 12-sided shape is called a dodecagon. Before I get to that N and tell you what that means, I want to back up a little and go back to the seven-sided shape. There are other words that you sometimes might know, especially from a chemistry class or a science class. So if you know another word, so like for seven, a lot of students know instead the word septagon. That is equally correct. One of them, I think the heptagon is a Greek word and septagon is a Latin word. I'm not sure about that, but I know they just have different origins. So if you know another word that you've heard in another class and you use that, I will give you credit. But we expect you to have these memorized. These are the ones that we would want you to have memorized. So if I ever use the vocabulary word octagon in a word problem, I'd expect you to know that it has 8 sides. Now the N is there because sometimes we'll have like a 13-sided figure or an 18-sided figure, and we don't give those special names. I know maybe there are special names you could find if you looked it up, but for us, anything that is above 12, we just use how many sides it has and then dash gon. So for example, if you were talking about a 15-sided shape, you'd call it a 15-gon. If you were talking about a 24-sided shape, you'd call it a 24-gon, and so on. So if I ever use that kind of wording, you know that that number is how many sides it has. And so it would have, a 24-gon would have 24 straight, non-intersecting sides. All right, a couple more vocabulary words before we finish this page. One of them you already know. Actually, there's 2 of them you already know. So the first one, you know this. If I showed you a picture that had 4 tick marks on it, like this shape off to the right, I hope all of you would be able to tell me it's equilateral. We saw that word when we were doing triangles, and it's the same for any other shape. If all sides are congruent, then that shape is called equilateral. Same with the second line. We saw when all the angles were marked the same, for us they were arc marks, and now it's the little box in the corner because we're looking at a rectangle. But no matter what kind of markings they use in the corners, if they're all the same, we call that equiangular. And again, we saw that with our triangles in the last chapter. So it applies to shapes that have more than 3 sides. If all the sides are congruent, equilateral. If all the angles are congruent, then equiangular. The last vocabulary word on this page you have not seen, I don't think, and it is the word regular. Regular means it has to have 3 conditions. It has to be convex, that's your first condition, and it has to be equilateral, and it has to be equiangular. Remember, convex means it doesn't go in on itself, or in other words, if you trace the sides, you don't end up inside of the shape. So if a shape is convex, equilateral, and equiangular, all 3 of those things, then we can call it a regular polygon. So off to the right, we're looking at a regular pentagon because all the sides have been marked the same way, all the tick marks are identical, and all the angles have been marked the same way. All the arc marks are identical. Just in case I ever use this word, the opposite of regular, which you probably already know, is irregular. So the opposite of regular is irregular. So even our rectangle up above, it has all the angles marked with 90-degree angles, so it would be considered equiangular, but it would not be considered a regular quadrilateral because all the sides are not the same. It would be considered an irregular quadrilateral. All right, so those are, well, there are a lot of vocabulary words on this page. I'm hoping that the number of sides in that table, you know many of those, so there shouldn't be a lot of memory work there, is what I'm hoping. You already know equilateral and equiangular from triangles, and so we have the word regular added at the bottom. So even though it looks like a lot on this page, I'm hoping you know many of those words. All right, in the last page, or on the last page, we're going to classify our polygons. We're going to practice classifying the polygon by how many sides it has, and then we're going to state whether it is equilateral, equiangular, or regular. And every year I say I should change these notes, and it looks like I forgot again. But really, we should also ask if it's convex, because there really are 3 conditions. And so I'm going to add the word convex up here, and hopefully one day I remember to change my notes. So there really are 3 conditions in order for a shape to be classified as regular. And if it fails even one of those conditions, it's considered not regular. All right, so first let's classify it. In part A, if you count up the sides, we have 1, 2, 3, 4, 5, 6. So this is considered a hexagon. All 6 sides have tick marks, all 6 angles have arc marks, and it does not go in on itself. It is considered convex. So we have a yes, yes, yes in our 3 tests. And so then, yes, it is regular. Again, you need those 3 tests. Yes, it's convex. Yes, it's equilateral. Yes, it's equiangular for the shape to be considered regular. In the second shape, let's classify it first. If you count the sides, there's 1, 2, 3, 4. If we just generically call this any 4-sided shape, it's called a quadrilateral. Later in this chapter, we'll learn even how to be more specific about what type of quadrilateral it is, but for today, we'll just call that a quadrilateral. All right, if we ask if it's convex, that first condition, the answer is yes. Again, it doesn't go in on itself, or as a reminder, if you trace any of the sides, you don't end up inside the shape. So yes, it's convex. For that second condition, is it equilateral? Yes, every single side has a single tick mark on it, so yes, it's equilateral. For the third test, is it equiangular? The answer would have to be no, because every angle does not have the same kind of arc mark on it. Some of them are single arc marks and some of them are double. And let me erase these extra lines I put on. So we're going to put a no in this space, but let me remind you, if you look at those angles, to use that common sense backup plan, we have some acute angles and some obtuse angles. So of course it's not equiangular. Some of them will be less than 90 and some of them will be greater than 90. So it cannot be considered equiangular. The markings should be how you really know that, but remember the backup plan of going by what they look like. And so the final answer on whether it's regular, it only failed 1 test, but that's enough to say it is not regular. So like I said, that one could also be called irregular, right? This is an spelling that wrong. This is an irregular shape. So that's a vocabulary word you might see once in a while. This one is an irregular quadrilateral. All right, the final example on this page, we could do some algebra in this section. Once we know things are regular, then obviously a lot of stuff is equal. There are sides that are equal, there are angles that are equal. And so if I tell you you have a regular shape, you could set 2 sides equal, set 2 angles equal. And again, it'd be kind of like when we were doing equilateral, equiangular triangles. Pick any 2. Pick any 2 sides to set equal, pick any 2 angles and set them equal. but please, please, please do not set a side equal to an angle. That does not make sense. So if we want to find the length of a side, we will look outside the shape, and we would look at the 3x plus 6 and the 4x minus 2, and we would set them equal. So 4x minus 2 equals 3x plus 6. If you solve that, you would subtract 3x from both sides. You'd get x minus 2 equals 6. Then you would add 2 to both sides, and you'd get x equals 8. Now, it did ask you to solve for a side. So you know me, on my tests, I would have a second answer line for you, and you can plug it into either the 3x plus 6 or the 4x minus 2. Doesn't matter. Either place, you'll get the same answer. So I'll do the 4x minus 2. 4 times 8 minus 2, 32 minus 2 is 30. Now, there's no dimensions, so I don't know. Maybe it's inches, maybe it's centimeters. We don't know, but it's 30. And I know I didn't ask you to do this, but we know the idea of perimeter now. We learned it when we were doing mid-segments in Chapter 4. So if I had asked you for the perimeter, you would be able to take that 30 and multiply it times 6, because we have 6 congruent sides. How do we know that? Well, we can count them, but also because in the directions it said you had a regular hexagon. So the number of sides is 6. And I'm not sure, I don't think I said this earlier, but n is something that always stands for the number of sides. It's the variable that we always use when we're trying to designate the number of sides. So n is your variable. All right, so 30 times 6 is 180. And again, I don't know, millimeters, centimeters, feet, who knows? But we could also calculate the perimeter, even though they didn't ask. All right, and then finally it says find the measure of an angle. So now we're going to be looking at what's happening inside your triangle and setting those two things equal. 2y plus 20 equals y plus 60. Subtract y from both sides. Y plus 20 equals 60. Subtract your 20. And y equals 40. It's not asking you just for y. Remember, it's asking you for one of your angles. So an angle is equal to, pick either expression that's circled in blue up there. So I'm going to pick the y plus 60. 40 plus 60 equals 100. And of course, we do know the units. All the angles are always measured in degrees. So we